Hello everyone, I am Dr. Godanda Raman. In this section, we are going to discuss with queuing theory introduction. Queuing theory is a powerful tool for modeling many practical applications. So this is a structure of the queuing process. All of us have experienced the inconvenience of having to wait in line. Customer arriving for service, server providing for service. After service completion, the customer leave the service area. This is the queuing process. So for example, we wait in the line our car traffic jam. We wait in the line at supermarket to check out. Why then is there waiting? There is more demand for service that there is facility for service available. Why is this so? There may be a shortage of available server. There may be a space limit to the amount of service that can be provided. We have some question. How long must customer wait? How many people will form in the line? So queuing theory answer. Queuing theory attempt to answer this question through detailed mathematical analysis. The queuing theory is a purpose of how long customer wait, how many people will form in the line. There's two questions to answer queuing system. Characteristics of queuing theory: arrival pattern of customer, service pattern of server, queue discipline, system capacity, number of service channel, number of service stage. Customer, here we use the term customer. General sense does not imply necessarily a human customer. It's a general. General means the customer, anything to consider customer. Airplane customer, laptop customer, so computer customer. So whatever we consider the general name customer is not only a human customer. For example, airplane waiting in the line to take off, a computer program waiting to be run as time shared basis. So this is one of the customer. Airplane is one of the customer. To discuss with some topics: bulk or batch, bulk, reneged, jockey. Bulk or batches is nothing but, so this is the structure of the process. So what is the bulk or batches? More than one arrival can be entering the system simultaneously. The input is to occur in the bulk or batches. Bulk the customer. So the customer decide not to enter the queue upon arrival. He is said to have bulk. Suppose the customer arriving for ATM or bank, whatever, the queue is long, the customer not join the queue, so they are leaving the service area. Reneging customer. Customer may enter the queue but after some time lose patience and decide to leave. This type of customer, reneged customer or reneging customer. Jockeying customer, two or more parallel waiting line, customer may switch from one to another. For example, the toll booth to consider. So the two parallel line to consider. If the lost car, one line, another when the another line is moving, suddenly the car switch to another line. Suppose the first line is moving fast, then this second line customer switch to the first line. So this is a jumping customer, considered jockeying. And when the system is empty, the service pattern of service, if the system is empty, the service facility is idle. The service may also be deterministic or probabilistic. Service may also be single or batch. One generally thinks of one customer being served at a time by a given server. But there are many situations where the customer may be served simultaneously by the same server. The service rate may be depend on the number of customer waiting for service, because it's a very difficult. If the bus only to provide service only single customer, it's very difficult to provide the service single customer. So the batch service maximum, the server will be provide the service. Server may work faster if he sees that the queue is building up. He may get plus flustered and become less efficient. The situation in which service depend on the number of customer waiting is referred to as state dependent service. For example, customer with parallel processing, people boarding a train. So this is a service, batch service we have to consider. Queue discipline, first come first serve or first in first out, is normally general service. We are following normal regular service, first come first serve based on. Last come first serve or lost in first serve, where it's happen. Some example, now I'm showing here one of the example, bangle. So when the bangle wearing, the lost bangle to remove first. So this is the one of the example. Now we consider any type of example, lift, last person to enter the lift, they are getting first. So this one of the example we should consider. Random selection for service, it's this type of discipline, the queue will not form because of before earlier we are getting the appointment for the hospital, whatever, we just getting appointment earlier to fix the service time. So this type of discipline, the queue will not form. Priority, primitive, non-primitive. See, one of the example we consider a hospital. So in the hospital, when we consider primitive, non-primitive, the primitive is nothing but the two type of customer we have to consider: low priority customer, high priority customer. The customer with the highest priority allowed to enter the service immediately, even if a customer with lower priority is already in the service, when the higher priority customer enter the system. This is a primitive case. Non-primitive case, the highest priority customer goes to the head of the queue but cannot get into the service until the customer presently in the service is completely, even though this customer has low priority. System capacity, finite capacity, infinite capacity. So what is a finite capacity? A queue with a limited waiting room, so that when the time reaches a certain length, no further customer are allowed to enter until space becomes available by service completion. Infinity is a queue with unlimited waiting room. Now see here, number of service channel, single channel, so one counter to consider. Customer arriving, server providing service, after service completion the customer leave the service area, single channel. Then multiple channel, more than number, two or more number of server providing for service. So these are the multiple channels. See here, customer arriving, so 3 server here. So after the service completion, the server leave the service, customer leave the service area. Number of stage, number of service stage. Single stage, so as usual we consider customer arriving, server providing service, after service completion the customer leave the service area. For example, beauty parlor, supermarket, theater and so on. Multiple stage, see, customer arriving for service, so server providing the service, again the customer need some more service, again to move on to the server, the server providing another one more service, then after the service completion to leave the service area. So this is an example, medical history, account opening, canteen. See, everybody we are using canteen in college. So look at canteen, first server, see the counter, consider counter is the first stage. So where we are getting the token from the counter, when we are paying we are getting the counter, receipt, bill, whatever. Now next counter, so food counter, so we are receiving the food from the another counter. Suppose we need some coffee, tea or juice, again we are moving to the counter, getting the bill, then again to move on the another stage. So these are the multiple stage to consider for number of service stage. This is a Kendall notation, A, B, X, Y, Z. A is a inter arrival time. So these are some distribution we consider: exponential, deterministic and Erlang, hyper exponential, phase type, general. These are some distribution we are following. And B, service time. Here also we are using similar exponential, deterministic, Erlang, hyper exponential, phase type, general we used. Now x number of parallel server, number of server we consider x. Y system capacity is a finite or infinite, and then z queue discipline, we have 5 discipline we have discussed earlier: first come first serve, last come first serve, random selection service, priority, and general. So queuing model: probabilistic or stochastic model, deterministic model, mixed model. So probabilistic model is nothing but when there is uncertainty in both arrival rate and service rate or assumed to be random variable. And deterministic model, both arrival rate, service rate exactly we know. Mixed model, when either the arrival rate or service is exactly known and then other is not known. So these are the queuing model. So this is a queuing theory introduction. Thank you.